Hello everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is LL of one parsing table. So what we are going to discuss here, what is the definition of LL1 and how to construct the LL1, and we are going to look after one example. So what is LL of one parser? These LL of one parser comes under top-down parsing. It comes under top-down parsing. So it is LL of 1 is nothing but the first L points to left to right and the second L points to it follows leftmost derivation, and 1 tells us the look ahead symbol. The input symbol tells us the look ahead symbol. If I have LL of K is nothing but K points to number of K look ahead symbols. K look ahead symbols. So if I write here 1 look ahead symbol. If I have 2 look ahead symbols. Okay, so LL of one parser is nothing but it is a left to right, leftmost derivation with 1 look ahead symbol. It is nothing but it is a type of context-free grammar that is used in parsing. It is mainly used in the parsing. It is one type of context-free grammar. See here, LL of one parser is nothing but scanning the input from left to right, leftmost derivation using one symbol at a time. Using one input symbol at a time. So what are the steps that are used to construct LL of one parser? So to construct the LL of one parsing table, the given grammar must satisfy. It should not have left recursion. It should not have left recursion. For example, the given grammar is consisting of left recursion. Nothing but it is in the form of A produces A alpha. Nothing but the LHS and the RHS are of same. Then it is having the left recursion. We need to override these left recursion. Okay, we need to avoid that left recursion. And it should not have unambiguous grammar. Each string should be derived only one way. Nothing but the given string, I cannot derive it in more than one way. Either left recursion or right recursion, left parse tree or right parse tree. So nothing but only one should be there. One tree I can generate. Left factoring. So here left factoring, make the grammar deterministic so the parser can proceed without any guessings. Okay. So the given grammar, that steps that are used to construct LL1 of parsing table is, it should be free from left recursion and it is unambiguous grammar and it is a left factoring. So algorithm to construct the LL of one parsing. First check all the conditions. We are going to check all the conditions. What are the conditions? I am having a grammar. The given grammar we are going to check it is free from left recursion. It is left recursion and it is a unambiguous grammar. We are going to check these conditions. If the conditions are satisfied, then we are going to calculate the first time follow function. In the top-down parser, we are going to calculate the first time follow function. Okay, so for which one we are going to calculate this first time follow function? For all the non-terminals. First is used to calculate for the non-terminals which are present on the left-hand side. We are going to concentrate on the LHS part in first function. Coming to the follow function, we are going to concentrate on the RHS part. So it is totally, we are going to calculate first time follow function for only the non-terminals. See, first, if there is a variable and from that variable, if we try to derive all the strings, then the beginning terminal symbol is called the first. So suppose A tends to B. So first of A is nothing but B. We are going to write it in the form of a set. So A is nothing but we are going to check for the first function. We are going to check the LHS part. We are going to check the LHS part. In the LHS, exactly right side RHS, the first symbol. If it is a terminal, that will be my first function. If I have a non-terminals, we have seen already there are some rules to calculate the first function. Similarly, for follow, the follow is calculated in the RHS part. Suppose BA, A tends to BA. Follow of B is nothing but in the RHS part, follow of B. B is followed by which number, which letter? Either it is a terminal or a non-terminal. If it is a terminal, we can directly write it. If it is a non-terminal or if nothing is there, we are going to follow some rules and we are going to calculate it. What is the terminal symbol which follows a variable in the process of derivation? That is nothing but follow function. That is the step 2. First step is we need to check all the conditions, like there should not be left recursion. It should be free from unambiguous grammar. Then all the conditions are satisfied. Then we are going to calculate the first time follow function. If that first time follow functions are calculated, then we are going to construct the table. So for each production A tends to alpha, First, find first of A for each terminal. First of A, make a entry in the table. Nothing but this is what type of, it is a LL of one parsing table. In this parsing table, first we are going to calculate first and follow. Then after calculating the first and follow, that should be placed in the table. So to place it in the table, we are going to concentrate, we are going to have the first functions and we are going to have the follow functions. If the first function is having A tends to alpha, then directly I can place it in the parsing table. If suppose I am having some epsilon is there, then what we are going to do here is, we are going to place this epsilon, means nothing but what is having the follow of A, there we are going to place it. There we are going to place it. Next, so we have two functions. To construct the parsing table, we are going to have two functions. Nothing but in the table, rows will contain non-terminals, and columns will contain terminal symbols. All the null productions of the grammar will go under the follow statements, and the remaining productions lie under the first set. Okay, so to construct this, the rows will contain the non-terminals and the columns will contain the terminal symbols. So this is the example. For this example, we need to construct LL of one parsing table. To construct LL of one parsing table, what are the conditions? It should be free from left recursion. And it is unambiguous grammar, and it should be a left factoring. If these conditions are satisfied, then we are going to construct first and follow function. So to construct first and follow function, again by default we need to satisfy these things. Okay, so after calculating the first and follow function, then we are going to construct the parsing table, LL of one parsing table. So to construct the LL of one parsing table, the rows will contain the non-terminals and the columns will contain the terminal symbols. So this is my grammar. For this grammar, we are going to calculate the first time follow function. So the same grammar I have written over here. So the first function, E tends to TE dash. So nothing but what it is, first of E. So what is first of E? First of E is nothing but exactly in the right hand side, what it is there. It's a terminal or it's a non-terminal. So if it is a terminal, then we are directly going to write here. If it is a non-terminal, we are going for that production, first of T. See here, E is there, first of E. I am having here, it is a T is there. It is a T. So what I am going to do, it is a non-terminal. So first of T. What we are going to, if I find a T, nothing but if I find a non-terminal, we are going for the T function. So nothing but T. So first of E is equal to first of T. Again first of T is a non-terminal. So we are going for the first of T. First of T is what I am having, first of F. So again first of F. So first of F is nothing but it is also a non-terminal. So again first of F. So first of F is what I am having, ID, comma, open bracket. So now first of E is nothing but ID, comma, open bracket. Next, first of E dash. What I am having here, plus. Plus is nothing but it's a terminal. And epsilon. In the first function, we will have epsilon. But coming to the follow function, we don't have the epsilon. We will have the dollar symbol in the follow function. And in the first function, we will be having the epsilon symbol. Next, T. Follow of T. Follow of T is nothing but F. F is followed by again this one. ID, comma, open bracket. So the E and T is having the same thing. Next, first of T dash is star. Star is nothing but it is a terminal and epsilon. Star and epsilon. Next, F. F tends to ID or open close bracket E. First of F is nothing but ID, comma, open bracket. So this is first function. Next, coming to the follow. Follow of E. So here to calculate the follow function, the first start function will have a dollar. Okay. Follow of E. So to calculate follow function, we are going to concentrate only on the RHS part, not on the LHS part. Okay, follow of E. Let me check in all the productions where I can find E. Here I don't have, it is E dash, and here I have E. So what it is following? E is followed by what? Closed bracket. E is followed by closed bracket. And dollar is nothing but, as it is start of my grammar, it is the start symbol of my grammar. So the start symbol of the grammar will have a dollar symbol. Dollar comma closed bracket. Next, first of E dash. So E dash is nothing but, see here E dash is the end of the symbol. If I have E dash at the end, we are going for the follow of E. What I am having follow of E? Dollar and closed bracket. Next, follow of T. T is nothing but followed by which one? E dash. T is followed by E dash. Here also T is followed by E dash. Okay, so if it is following by a non-terminal, we are going to calculate it as first of E dash. What is first of E dash? Is nothing but plus comma epsilon. See here, follow of T. Follow of T is nothing but E dash. First of E dash. What I am having? Plus comma epsilon. So place this plus and epsilon in the after the T. Okay, so follow of T is nothing but, it is followed by E dash. So what I am having here? Plus TE dash. Plus TE dash is nothing but, not plus TE dash. Let me go for the first one. TE dash. Follow of T is nothing but E dash. In the place of E dash, place plus and TE dash place epsilon. E produces. Okay, so E produces T plus. T plus is nothing but what? Follow of T is nothing but, follow of T is equal to, T is followed by which one? Plus. And here epsilon. Epsilon is nothing but empty. Nothing is there. So empty is nothing but, it became T. So follow of T is nothing but, it is followed by follow of E. So what I am having follow of E? Dollar comma closed bracket. So this is of follow of T. So follow of T is nothing but, T is followed by E dash. E dash is a non-terminal. So we are going for the first of E dash. So first of E dash I am having plus comma epsilon. Just directly substitute plus and epsilon. Epsilon is nothing but empty. So nothing is there after here. So directly it is going for follow of E. Follow of E is nothing but, these things are copied over here. Next, follow of T dash. So follow of T dash is nothing but, here I have follow of T dash. After T dash, no element is there, no terminal or non-terminal. So directly follow of T. Follow of T is nothing but plus dollar closed bracket. Next, follow of F. F is followed by T dash. Follow of F. Follow of F is nothing but first of T dash. First of T dash, what I am having? Dollar star comma epsilon. Star comma epsilon. So here follow of T. Follow of F. So T tends to F T dash. So I can write this one as F star or F. So follow of F is nothing but, I am having star, and other one is F only. Here epsilon is nothing but, nothing is there. So follow of F is nothing but follow of T. So what I am having follow of T? Plus dollar closed bracket. So this is nothing but follow of F. So first time follow functions. First thing we did, we are going to check the conditions. Then afterwards, we are going to calculate the first time follow function. After calculating the first time follow function, now we are going to plot this first time follow in the parsing table. Here to calculate, it is make a parser table. Now the LL1 parsing table is this one. So the rows are having the rows are nothing but the non-terminals and the columns are the terminals. Here the dollar is telling us, here the string is accepted. The dollar tells us the string is accepted. First time follow we have calculated. Now we are going to construct the LL1 parsing table. So to construct the LL1 parsing table, we have seen the first function is what I am having. E tends to TE dash. What are the things of first? First of E. I have ID comma open bracket. First of E is ID comma open bracket. So in the place of ID, we are going to just place that particular production. So these ID and dollar we got from these one. E tends to E produces TE dash. So we are going to check the whole grammar. What are the first functions? If I have a epsilon, we are going for the follow. If I don't have epsilon in the first function, directly we are going to plot this. What are the terminals we got in the first function? That subset, we are going to write the exact production over there. So E produces TE dash. Wherever I need to write in my parsing table, in the place of ID and in the place of closed bracket. In the place of ID, I have written E produces TE dash. In the place of open bracket, E produces TE dash. First thing, here how we got these non-terminals? Non-terminals are what are the non-terminals that are there in my production, and terminals, what are there in my production, the terminals, those things only I am writing. Plus star ID, open bracket, closed bracket, and here I have epsilon. So we won't write in LL1 parsing table epsilon. We will write the dollar. Dollar indicates that it is my end of the string. So that's why we got these many. Next production. E tends to E dash produces plus TE dash or epsilon. So what I have here in my first function, plus comma epsilon. Plus, how I got plus? By using these first production, I got plus. By using the first production, I got plus in the first function. So in the place of plus, we are going to place the first production. So this is nothing but what it is. E produces plus TE dash, E produces epsilon. E produces epsilon. So these are the two functions. We are going to write it in a single statement. So by using this statement, I got this one. By using this statement, I got plus. So in the place of plus, we are going to write E dash produces plus TE dash. E dash produces plus TE dash. The other one here I am having is epsilon. How I got these? I got these epsilon. So if in the first function, if we have a epsilon, we are going for the LHS, follow of E dash. What I am having follow of E dash? Dollar comma closed bracket. Dollar comma closed bracket. In the place of dollar comma closed bracket, we are going to write E dash tends to epsilon. In the place of closed bracket and dollar, we are going to write E dash tends to epsilon. E dash tends to epsilon. I got plus just because of this production. I got these closed bracket and dollar with the help of this epsilon. So the next one, T produces FT dash. T produces FT dash. So what are the first values, first functions? ID comma open bracket. In the place of ID comma open bracket, we are just writing T produces FT dash function. ID comma open bracket, T produces FT dash, T produces FT dash. Next, T dash tends to star FT dash or epsilon. What are the first functions? Star and epsilon. So I can write this one as T produces FT dash, T dash produces epsilon. Epsilon. So this star I got with the help of this function, with the help of first function. I got this epsilon with the help of second function. So in the place of star, I can write T dash. In the place of star, I can write T dash tends to star FT dash. Now, so in the place of epsilon, I got epsilon. So to construct a LL1 parsing table, in the first function, we should not have epsilon. If suppose we have is epsilon, we are going for the follow of T dash. We are going for the follow of T dash. So if ever we find epsilon, we are just going for the follow of T dash. What is follow of T dash? So in the place of plus, dollar and closed bracket, plus dollar closed bracket. In the place of that, I need to place T dash tends to epsilon plus closed bracket dollar. I got T dash tends to epsilon, T dash tends to epsilon, T dash tends to epsilon. Next, F produces ID comma ID or open close bracket E. So what is the first function? ID comma open bracket. Here I have two functions are there. With the help of one function, I got one set. With the help of other function, I got some other letter. So nothing but how I can write these function as f produces id, f produces open close bracket e. So with the help of these function, I got id. With the help of these production, I got this open bracket. So in the place of id, I need to place f produces id. In the place of open bracket, I need to place f produces open e close bracket. Why? Because with the help of these f produces id production, I got this id. With the help of these production, I got this one. These two productions I merged and I have written in a single statement. So when we are going to construct the LL1 parsing table, we need to separate those, and based on that we got the first functions. We need to segregate and we need to copy it in the parsing table. So here in the place of id, f produces id. In the place of open bracket, we are writing f produces e dash. F produces e dash. So this is about the LL1 parsing table. So what are the things we have learned over here is, so we need to check what is LL1. It is nothing but it is a left to right. LL of 1, it is nothing but left to right and left recursion, and 1 is nothing but only one look ahead symbol we are going to concentrate. So take a grammar and check the grammar is free from left recursion and it is unambiguous and it is a left factoring. After doing that, we are going to construct the first time follow function. If the grammar is free from all these conditions, we are going to construct the first time follow function. After calculating the first time follow function, we need to construct the LL1 parsing table. To construct the LL1 parsing table, we are going to concentrate mainly on the first function. So when in the first function, if we find epsilon, we are going to replace these epsilon with the follow of e function. Why? Because in my columns, there is no epsilon function. So when we construct the LL1 parsing table, we won't write epsilon in the rows. We are going to write only the dollar. Why? Because the dollar indicates me that the string is accepted. That is my end of the string. So when we take an input string, it tells we are going to write a dollar at the end. So that indicates me that I have completed reading my string. So further, we are going to write here dollar. We are not going to write epsilon. But when we calculate the first function, we are going to use the epsilon. So to construct these LL1 parsing table, so these non-terminals and these terminals are written from the given grammar. For the grammar which we have constructed first time follow function, from that grammar only we are going to take the non-terminals and terminals and we are going to plot it. Thank you.